In this video, we'll look at question 40 from the 2016 exam. So in this question, we have a solid cube which rests with one of its edges on a table, so that its side is at 30 degrees to the horizontal, side length d, but it doesn't tip over because there is another force, P, acting on the opposite edge, horizontally to the right-hand side. We are supposed to decide which of the following four statements will be true. So the first three say that there's possibly no friction between the cube and the table, with one more L that would be necessary, like this. Second says that there must be a friction force acting to the left here. The third one, the opposite, that there must be a friction force to the right. And then the fourth is a bit unrelated, that B actually has a moment of force of magnitude P cross D around the edge. So let's first look at the first three statements and decide what the friction force will be. Okay, so what are all the horizontal forces acting on the cube? There is this force P, then there will be a force of gravity, but that's always downwards, always vertical. And now because it has to stay stationary, the whole cube, there also must be some sort of force to the left of magnitude P to counteract that force. And the only place where it can act is as friction on the bottom edge. So 2 is definitely true, and that makes 1 and 3 incorrect. But how about statement number 4? Okay, so there definitely is a moment that P has around this bottom edge. The cube can rotate around it, but both the direction and the magnitude are wrong. The magnitude would be P times this whole distance here, not just D, but the whole distance, that's root 2 times D. The force is actually clockwise. Moreover, the moment, or the torque, is always perpendicular to both the distance and the force. So in this case, it would either point out of the page or into the page. So the only part which is actually correct is that P has a moment. Both the direction and the magnitude are wrong. In any case, 4 is incorrect. 2 was the only correct statement, which makes B the right option to pick.